Hey guys, in this video we're going to take a look at solving a systems of equations by the elimination method, which is the second method that is talked about in section 6.1. As far as the final is concerned, the problem from this section that's on the final does not specify whether you use substitution, which I did in the other video, or the elimination method, which I'm going to show you here. It's entirely up to you which way you want to do it, so you can pick whichever one you like better. Solving by the elimination method is a little bit easier to do on more systems. Substitution is probably the easier of the two methods, but it only works well if you've got a variable in one of the two equations that has a coefficient of 1 or -1 usually. Otherwise, you're going to run the risk of creating a bunch of fractions that you probably don't want to have to deal with as you're working through the substitution problem, okay? And this solving by elimination kind of avoids that. What we're going to do is we are going to add the two equations together. And we got to do a little something to them first so that when we add them together, we're able to actually eliminate or get rid of, add out to 0, one of the two variables, okay? So your first step here would be to choose either the x's or the y's to eliminate, okay? I'm going to go through this. I'm going to pick the x's. I want to get rid of the x's, okay? So what I have to do is look at the two coefficients on those two terms and find the least common multiple. That's the smallest number that both of these will go into. Then I'm going to need to multiply either one or both equations by a number so that the coefficients on these two terms are that least common multiple, but opposite signs. Okay, so I need one positive and one negative of that least common multiple. So 3 and 2 have a least common multiple of 6. Alright, so one of these two needs to be a positive 6 and the other one negative. It does not matter which one you use. If we were going to do the y's instead, if we look over here at the y's, we have a -4 and a +5. So the least common multiple there would be 20. And you already have that opposite sign thing going on for them, so you would just need to multiply the top by 5 to get 20 here, and the bottom by 4 to get 20 there. Okay, so you could go either way with this. What I'm going to do is multiply the top equation by 2, and you do the whole equation, not just the 3x, otherwise it does not stay balanced. And the second one I'm going to multiply by a -3 to make this one the -6x. Okay? So I'm just going to multiply these and pull them over here to the side. So if I distribute the 2, I get a 6x minus 8y is equal to 20. And the -3 goes through, giving me -6x minus 15y is equal to 3. Okay? Now, once we get the two terms that have the same number, that least common multiple, but opposite signs, we'll add each column. And what's going to happen then is, like the x's in my case, they're going to add out to 0. And so I'm just left with a little equation that's got y's. This is going to come out to be a -23y and a constant, and that's going to be a positive 23, okay? Once that's done, you solve for that variable, which is going to give me y is equal to -1, and you're halfway done. Now, if that happens to be an ugly fraction and you don't want to plug it back in, like I'm going to plug this -1 back into one of these two original equations to get the x. If this is 18 over 23 or something like that and you don't want to deal with plugging it back in, you can repeat what I just did, except solve for the other variable. So like I could eliminate the y's the next time and it would give me my x coordinate just like I got my y coordinate this way. Okay? So there's a way around it if you don't want to plug it back in. Now, if you can plug it back in, that's definitely the easier route to take. So that's what we're going to do. I'm going to choose that second equation right there. It really doesn't make any difference which one you pick. I just randomly picked that one. And we plug -1 in for y. So that's going to be a 5 times -1 right there. And then we just solve this for x. So I can move the 5 over. 2x is equal to 4. So x is going to be equal to 2. Your answer is always an ordered pair because it's actually the point of intersection between the graphs of those two equations. So our solution would be 2, -1. Okay? And that's how you do the elimination.